is divided into three modules. In the first module, we will discuss about the wind energy technology. First of all, we will discuss about the types of the wind turbines. Wind turbines are divided into two types mostly based on the orientation of the axis. The first one is the horizontal axis wind turbine and the second one is vertical axis wind turbine. And within these, there are subtypes of the wind turbines like VAWT, under the vertical axis wind turbines there are gyro and other type of wind turbines, and under the horizontal axis mostly the floating type of wind turbines. Okay, so as you can understand with the name, in the horizontal axis wind turbines, the uh, axis of the rotor is parallel to the ground, and in the vertical axis wind turbine it is perpendicular to the ground. Okay, and mostly the horizontal axis wind turbines are largely applied for the large wind turbine forms, and in the application of the onshore and offshore area also. And this technology have a advantage of having very high efficiency, and it is highly scalable and proven technology. However, it has some limitations like it requires a uh, you know large control. Okay, and in the vertical axis turbines, these turbines are mostly applied in the urban area and in the very small scale, right? However, this vertical axis turbines have the advantage of directional, and it works in a compact area. Okay, and it also works in the turbulent winds where the wind flow is not steady. Okay, however, this vertical axis turbines are having some limitations in the terms of it has the lower efficiency, and it is very less common. Okay, now coming to the working principle of the wind turbine. Usually, rotor of the wind turbine moves with the wind action, and the rotor movement influences the gearbox, which transfer its energy to the next relay attached with the gearbox, and with the next relay there is a electricity generator is attached, and that generator produce electricity due to the movement of the rotor. Okay, and that produced electricity is transferred to the transformer through power cables, and then it is connected with the national grid or conventional grid. Okay, so you know there have been a lot of innovations in the wind turbine development. Nowadays, there are larger turbines are produced with the advanced materials like carbon fibers, other lightweight composites, and this have a high impact on the reducing the weight of the windmills or wind turbine installations. Okay, and this has also improved the durability of the wind farms. Okay, and there have been also smart technology integrated like sensors, AI, predictive analytics to how much wind will be there to produce how much electricity, and according to that the maintenance and optimization of the performance of the wind turbines can be carried out. Okay, and there are also innovation related to the gear drive, like now all the wind turbines are connected with the direct drive generators, which eliminates the direct application of the gearbox. Okay, and as we remove the moving parts in any machine, it improves its reliability and durability. Okay, so the direct drive generators requires lower maintenance, and it has a higher reliability. Okay, also nowadays wind turbines are coming with the hybrid system in which wind turbine is you know integrated with the solar storage, and in this way the power supply from the wind farms can be more stable and reliable. Okay. Now coming to the modern wind turbines, there are I have already discussed the components. So mostly the modern wind turbines consist of the large rotor diameters and tall towers, and this high advanced control systems, and it is also designed with the modular systems, so that any part which is getting damaged during the operational hours, so not the whole installation is required to replace. Okay, only the part which is damaged, uh, that part is removed and replaced. Okay, and it is also coming with the grid integration, advanced materials, and direct drive generators, also eliminating the need for the gearbox. Okay, now coming to the parts of the wind turbines, here you can study the different parts of the wind turbines which is associated. Okay, and all these are listed here. Okay, now coming to the worldwide wind power development. Country like China, USA, Germany, UK, India, and Brazil are one of the front runner in the terms of utilizing their wind power. China has the largest installed capacity for the wind power tapping, and it is also rapidly expanding its capacity. US has a significant onshore and offshore installation for the wind energy mm, tapping, and they are having a very strong policy support for tapping their wind energy. Okay, and Germany is one of the leading offshore wind energy tapping country in EU, and it is also giving a lot of push through the policy interventions in the renewable energy sector. Okay, UK is one of the major offshore uh, wind projects leading country, and it is also having ambitious targets to achieve a higher renewable energy, mixing with the typing of the wind energy technology. Okay, and India is having a lot of potential for the wind power, and the wind installation in India is also growing, with a focus on the higher percentage of the renewable energy technology in the Indian energy mix. Brazil is also expanding its wind energy sector with some. They are having a large coastline to tap their wind energy. Okay, these are the some basic differences between the onshore and the offshore uh, wind turbines, and it's also comparison with the floating wind turbines. Okay, now coming to the module 2, which is on the biomass technology. In the first part we will discuss the thermochemical conversion. Okay, so mostly the products which we get through the thermochemical conversion of the biomass for the bioenergy is mostly syngas, or you can say pyrolysis gas also, depending upon the processes, and bio-oil and biochar, and in the combustion we get heat and power. Okay, so the processes which are considered for the biomass to bioenergy technologies are the combustion, gasification, pyrolysis, and torrefaction. Torrefaction is nothing but just the pre-pyrolysis. Okay, and for converting biomass into bioenergy, biomass constituent is the most important factor. Okay, so and it is characterized with the lignocellulosic analysis. So the biomass having the higher lignin content, that is prone to produce the more biochar. Okay, that means the solid fuel, and the biomass which is having higher lignin content, that are subjected to the pyrolysis process. Okay, and the biomass which is having more lignin content, that is also having the higher heating value conventionally. Okay, cellulose and hemicellulose constitute the volatile part of the biomass, and it is released as a volatile matter which can be converted into the condensable gases or non-condensable bio-oil. Okay, so mostly the feedstock which is having higher content of the cellulose and hemicellulose that are subjected to the gasification. So that biomass is mostly converted into syngas, and later on it's applied in the engines integrated for the energy production, like running the mills or producing electricity. Okay, so the other characteristic which is play important role in biomass for the bioenergy is the ash content. Biomass with the lower ash content is preferred for the bioenergy conversion, and biomass with the higher ash content is less favorable as it causes slagging in the gasifier falling. Like these all are the technical challenges. Okay, also biomass with the lower moisture content is preferred for the bioenergy conversion. As you know, the moisture in the biomass takes out the heat, useful heat. Okay, so and it lowers the energy conversion, or you can say higher moisture content in the biomass increases the energy penalty. Okay, of the biomass to bioenergy conversion. So the biomass with the higher moisture content is less favorable for the energy conversion. So in these kind of biomass which is having higher moisture content, they are pre-dried. Okay, now coming to the biomass pre-treatment and pre-processing. So if the biomass is having the higher moisture content, it is pre-dried, or to remove the moisture, and this can be done with the sun drying, solar drying, and preheating also. Again, the biomass is not always in the same size as it is required in the furnace or boilers or in the reactor. So there are some size reduction processes is done for the larger size of biomass, like wood logs. Okay, so it is grinded or chipped or milled to reduce its size. Okay, sometimes the biomass densification is done when the biomass is having very less density. So usually briquetting and pelletization is done for the biomass. This is to enable the transportability of the biomass. Okay, so if the bulk density is higher, so its transportability is higher. Okay, as you know, the biomass with the lower density have higher transportation cost. Okay, sometimes biomass needs cleaning or washing just to remove the impurities or the non-combustible portion which is attached mostly with the biomass during the procurement. Okay, and sometimes it is also subjected to the biochemical pre-treatment like hydrolysis and enzymatic conversion or fermentation. Okay, there are various factors which of for the thermochemical conversion process, like for the combustion, gasification, pyrolysis, torrefaction, hydrothermal carbonization, briquetting, and pelletization. Mostly now for the thermochemical conversion processes like combustion, gasification, pyrolysis, torrefaction, hydrothermal carbonization, the temperature range is very important, and the conversion atmosphere is very important. Just for the example, combustion happens in the complete, supply or sufficient supply of the oxygen, where gasification there is very limited supply of oxygen. And in the pyrolysis, there is no oxygen. The environment has to be inert. Okay. Similarly, in the torrefaction, the environment has to be inert, and in the uh, briquetting and pelletization, there is no such, inert environment or oxygen environment is required. Now coming to the advantages and challenges of the thermochemical conversion process. So Combustion have the advantage of it is one of the oldest technology and which is very mature, but nowadays there are concerns with the direct combustion due to its direct emission and very low efficiency. Also, similarly, coming to the gasification, gasification gives you the syngas, which is very versatile in nature, and this gasification process is having the very high efficiency. However, tar management, which is the combustible volatile matter obtained from the thermochemical conversion of the biomass, and related regular cleaning is one of the biggest challenge in the gasification process. Pyrolysis gives you the all the three types of the bioenergy products, like solid in the form of biochar, liquid in the forms of bio oil, and gas in the forms of pyrolysis gas. However, there are challenges related to the bio oil processing and its mm, upgradation for the drop in fuel, and pyrolysis is also a very complex process, and it needs a lot of expertise for the mm, running the pyrolysis plants. Okay. uh, Torrefaction and hydrothermal carbonation is nothing but a part of the pyrolysis process, or can be explained in a similar terms of the pyrolysis. Now coming to part 2 of the biochemical conversion of the biomass. Mostly feedstock with the higher hemicellulose and cellulose composition is subjected to the biochemical conversion process, and the bioslurry which is left at the end of the biochemical conversion process is mostly the lignin and as part of a biomass. Okay. And in biochemical conversion process there are mostly microbial action through hydrolysis, fermentation, or aerobic or anaerobic digestion. From the aerobic and anaerobic digestion, mostly biogas is produced, which is high in methane. And in hydrolysis and fermentation, we mostly get the liquid biofuels, which is bioethanol. Okay, so for the converting biomass into bioenergy products through biochemical conversion processes, there are various type of the bioreactors. Okay, which is mentioned here. You can go through it. Okay, and these are the methane yield for the most of the common substrates or feedstock, like food wastage have the highest methane yield through the anaerobic digestion, which is about 0.35 to 0.45 meter cube per kg of the volatile solid. Okay, and it is because of the high organic content in the food waste. Okay, then next is the cattle manure, then pig manure, sewage sludge is also having a considerable amount of the methane yield through the anaerobic digestion. And there are some energy crops also which is utilized for the uh, biomethane production. Okay, and this is also having the one of the highest methane yield due to the high cellulose and low lignin content in these bioenergy crops. Okay, so anaerobic, coming to the processes related to the bioenergy conversion through the biochemical conversion process. Anaerobic digestion is one of the most suitable and favorable system for municipal solid waste. Okay, and there are other biochemical conversion processes like vermicompost, which converts the biomass into nutrient rich compost, and which can be applied in the soil, agriculture soil, horticulture soil, and for the carbon sequestration. Okay, and these are the some type of the designs related with the biogas plants, which can convert animal waste into the biomethane. Like there are fixed drum, floating drum, plug flow, And there are balloon type of also biogas plants which store the biogas generated from the digester in a balloon. Okay. Now coming to the part 3 of the module 2, which is on the liquid biofuels. I have already mentioned the hydrolysis and the fermentation process is mostly applied for the biomass to conversion into the liquid biofuel through biochemical conversion process. In this biofuel conversion, the feedstock is classified into first generation, second generation, third generation, and fourth generation of the feedstock. In the first generation feedstock, mostly edible oil seeds, sugarcane, corn, these all are the considered for the biofuel conversion, and it is termed as the first generation of the feedstock. And mostly we get the biodiesel and bioethanol from the first generation feedstocks. In the second generation feedstock, it is mostly the non-edible oil seeds and the crop residue. And again, biodiesel and bioethanol are the main product obtained from the second generation feedstocks. In the third generation feedstock, it is algae, and bio-oil and biodiesel is mostly produced from the algae. And in the fourth generation feedstock, mostly photosynthesis microorganism are considered as the fourth generation feedstock. And this fourth generation feedstock is mostly gets converted into uh, directly converted into the biofuel. Okay. And these are the non-edible wild seeds which are mostly considered for the biofuel production. They are like Jatropha, Karanja, Castor, and Neem. Okay, and they have actually very high oil content, and that's why they are having very high economic return in the on the investment. Okay, and the oil content in these feedstock mostly varies from 30 to 50%. So you know um, it carries a very high economic value. Okay, and these are the steps involved in the oil extraction from the these processes like seed pre-processing, oil extraction, oil refining, and then coming to the esterification, and then product separation from the yield. Okay. So for the biodiesel, there are various steps involved in the refining process like feedstock preparation, mostly then esterification, and then product separation, and then purification. Okay. And these are the characteristics of the biofuels, which is in the liquid forms, considered for the characterizing it as a suitable liquid fuel. Okay, these parameters include density, which is having the importance for the fuel injection and the combustion efficiency. Viscosity is very important parameter for atomization process and the engine bearing wearing. Okay, flash point is also important for the ignition temperature of the liquid vapors in the engine, and this is very important for the safety purpose. Calorific value, similarly ketone number, sulfur content, water content, and the oxidation stability. Okay, these are the characteristics which is mostly considered for the considering the suitability of the liquid fuels for the drop in fuel. Okay. Now coming to the next, which is the methanol production from the biomass. Mostly methanol is produced through the hydrolysis and the fermentation, and then it is subjected to the um, um, uh, chem, uh, uh, chemical changes. Okay. Now coming to the ethanol production from the lignocellulosic biomass. mostly feedstock which is having higher cellulose content and hemicellulose content are considered for the lignocellulosic biomass for the bioethanol production. Okay, and this process have similar steps like feedstock preparation, pre-treatment, enzymatic hydrolysis, then fermentation, then distillation, and then dehydration to convert it into the high purity of the bioethanol. These are the some applications of the liquid biofuels. Like mostly the liquid biofuels are used in the transportation, power generation, industrial processes, also for cooking and heating purposes. Okay, now coming to the module 3, which is the last part of this course. This is on the other renewable energy technologies. In this, we will consider the geothermal technology first of all, and geothermal technology is nothing but to tap the geothermal energy for the power generation. Okay, and there are certain advantages and limitations related with the geothermal technology. Like this geothermal technology is very simple and efficient. However, it requires a very high temperature steam source to tap the geothermal energy. Okay, and these geothermal technology is also subdivided into some three parts like dry steam, flash steam, and the binary cycle. And in the flash steam cycle, it has the advantage of being the most common and very efficient process. However, it requires high pressure reservoir. So there is a binary cycle of the geothermal technology has been developed, which eliminates the limitations of the dry steam and flash steam and incorporates the advantages of the dry steam and flash steam technology. Now coming to the application of the geothermal energy, the mostly applications are for the electricity generation, district heating, and in the agriculture purposes, industrial usage, and the geothermal heat pumps. Okay. However, there are certain advantages and environmental considerations related with the geothermal energy. Like although this geothermal energy is renewable and produce heat on a continuous basis, there are certain environmental considerations like potential. Uh, it has a potential of inducing seismic activity. It also, there are although there are minimal GHG emissions with the processes, but there are some emissions of the trace gases which are the environmental concerns like H2S and CO2. Although the technology of the geothermal energy, tapping the geothermal energy is very reliable and is having very high capacity factor with 24 into 7 operations, there are water usage and the management challenges related with the geothermal energy. Okay, and also it has a very competitive cost of the production. However, it requires a very large area. Okay, so tapping the geothermal energy has a competitive nature of with the habitat disturbance. Okay, the next one is the wave energy. Wave energy is nothing but tapping the waves, energy from the waves. Okay, and there are certain parameters which is very important in the typing the character waves, and these are some characteristics like wave height, wave period, wavelength, and the power density. Okay, so these are the characteristics which are very important in estimating the and quantifying the wave energy from any source. Okay, and there are various type of convergent technologies for the wave energy. The first one is oscillating water column. The second one is point absorber. The third one is overtopping device, and the fourth one is alternator. Okay, you can quickly go through the advantages and the limitations of these technologies. Okay, however, although the wave energy is considered as the renewable energy, there are also really some advantages with the tapping the wave energy, and there are some challenges in the tapping of the wave energy. Okay, advantages includes the as it is a continuous and very abundant in the nature. It has the leverage of the low emission and low pollution, and the it has a higher efficiency and energy density than the wind and solar, and with the modern advanced technology we can predict the patterns of the wave energy, so we can consider the wave energy is the one of the reliable kind of the technology. Okay, and there are certain perspective of its integration with the conventional grid. However, there are certain challenges related with this the wave energy, like variable wave intensity, potential marine ecosystem impact. There are harsh marine environment, and there are also very high capital investment and the maintenance cost required for the typing of the wave energy. Also, now the wave energy locations can be very offshore, and this can have some certain operational and logistic challenges. Okay. Now coming to the tidal energy, there are also the similar kind of the advantages and challenges related with the tidal energy, which is associated with the wave energy. Okay, advantages include the predictability, renewable and clean. The tidal energy is also having the very high energy density. It is also reliable and consistent, and the tidal energy systems can have a very long lifespan. However, there are certain challenges such as very high capital cost, environmental impact. These are the typing of the tidal energy is very site specific, and there can be maintenance difficulties, and there are some certain challenges related with the grid integration, because of the you may not have the grid accessibility at the every site of the tidal energy systems. Okay, there are some successful examples of the tidal energy projects, like in France, Scotland, UK, South Korea, Canada, and US. And in India, there are many potential sites for the tapping the tidal energy, like in the Gulf of Kutch, Gulf of Khambat, Andaman and Nicobar Islands, and Lakshadweep area. Okay. Now coming to the ocean thermal energy. Uh, there are temperature differences in the various section of the ocean surface to the bed floor. Okay, and again there are certain you know temperature differences with the intermixing of the cold and hot ocean currents, so that energy can be tapped for the electricity generation. And there are certain parameters related with the typing the ocean thermal energy, like surface water temperature, deep water temperature, and the temperature difference, like the temperature difference should be greater than 20 degrees Celsius. Okay, also the uh, depth of the intermixing of the water, cold and hot ocean waters. Okay, and water flow is also a very important parameter in typing the ocean thermal energy. Also, there are certain advantages and challenges related with the ocean thermal energy, like advantages include it is continuous, and there is no direct emissions related to it, and Stable ocean temperature gives you the predictability of the generating the or tapping the ocean thermal energy. Okay. Also, it can have the 24 into 7 power generation and supply. Okay. And however, there are certain challenges related with the ocean thermal energy, like it's a low thermodynamic efficiency. The temperature difference is only 20 or 30 is not uh, going to give you very high uh, advantage on the tapping the energy for the electricity generation. Okay, this temperature difference. Also, there are very high capital cost and operational cost related with the tapping the ocean thermal energy, which makes it a very costly proposition. Also, there are some engineering related challenges for tapping the ocean thermal energy, and some environmental concerns related to the marine life and the also the geography of the ocean thermal energy sites. So this slide, summarizes all the type of the integration challenges and the impact consideration for the other renewable energy technology like geothermal, wave energy, tidal energy, ocean thermal energy. And these are the strategies to overcome the integration challenges of the other renewable energy technology like um, uh, advanced grid management and control can be introduced to you know integrate the renewable energy technology with the conventional grid. Also, infrastructure investment, hybrid systems, environmental uh, monitoring, and the policy and regulatory support can, remove the hurdles of integrating the renewable energy technology with the conventional grids. This comes to the end of the course, and thank you for your attention.